Okay, here's a funny one. Let's start by talking about why this is strange. Well, the square root here, this is approaching 0. Okay, when you plug in 0, you can see that. But the sign is approaching, it's very strange. So let's talk about why it's strange. So if x goes to 0 plus, let's just look at a one-sided limit here. What are we thinking about here? We are thinking about sign of infinity. That's what we're thinking about. That's why I'm using the quotation marks. That does not exist. Why is that? Well, because if you think about sine, it just waves forever, right? It doesn't stop waving. It's going up and down, up and up and down, forever, forever. Is it approaching anything? No, it is not. It is waving forever. Okay, so it's not approaching anything, so the limit here does not exist. Okay, so I hope this convinces you that this limit does not exist. So we have something going to 0 times something that does not exist. So what's going to happen? Well, we're not sure right now. You may guess 0, and as the final answer, you may guess 0 for the final answer, and you'd be right, but you would not be, your solution would not be justified. You have to give some better reasons for why this ends up being 0. So the tool we're going to use is called the squeeze theorem. So I'm just going to use it, and then I will state the squeeze theorem afterwards. So I'm going to start by saying that, as with any theta, we are stuck between -1 and 1. Okay, so if you, now this thing I got a rectangle around, this is just something you're expected to know from the graph of sine. It goes between -1 and 1. Okay, so that's true for sine of 1 over x as well, right? Okay. Now, what I'm trying to do is I'm trying to make this guy appear in the middle of this inequality here. So what I can do is multiply all three parts, 1, 2, 3, multiply all three by this square root. So I'll do that. I get negative square root blah, blah, blah is less than or equal to square root blah, blah, blah times sine 1 over x less than or equal to, oopsie daisy, the square root of blah, blah, blah. All right, so I have this inequality, which I hope you agree is justified. Now, what we're going to argue is that this guy, the limit here, is 0. Okay, when x goes to 0, this dude goes to 0. And then we're going to argue that over here, this guy also goes to 0. So my function that I care about is stuck between these two things, and those two things are both going to 0. So I conclude that this limit, this limit is 0 by, well, it may seem just common sense to you, but we summarize this or formalize this in something called the squeeze theorem. Okay, so what we argued was that our function is between two things, And those two things are both going to the same limit. That's key, right? So my limit is smushed in between them, and it must also be 0. Okay, so hopefully that makes sense. To formalize this, I will now state the squeeze theorem, and you should copy this into your notes. So yeah, copy that in. Okay, it's saying the same thing that I said above, but more formally and more generally. Okay, you have G is stuck between F and H and H are both going to the same limit L. And I'm allowed to conclude that that guy in the middle is also going to L. So, we're saying F goes to L, H goes to L, and squeeze theorem says that G will go to L as well.